integral from 1 to 2, y to 4, f x comma y, dx dy. Okay. So since you have dx here, you should think of x being here. And you have to draw the graph of x equal to 4 and x equal to y. X equal to 4 is a vertical line, right? 1, 2, 3, 4. And it's a vertical line that's like that. What's x equal to y? Usually you want to write y equal to. So if you view this as y equal to, it's y equal to x. I know that. Y equal to x is this. Okay. And then 1 to 2. Here's 1. Here's 2. Oh, no, that's not right. What am I doing? For a moment, I thought these were x values, but these are y values, right? So what's y? Y is 1. Y is 2. Okay? And therefore, if you draw the domain that's being integrated, first, dx means you're moving that way, right? And your height is limited to be from 1 until 2. So your brushes are only being doing the painting in between. So this is what you get. All right. So you have that. Now we have to try to paint this upwards, because the question is, I should have stated the question first. Switch the domain of integration, switch the order of integration. So I need to go from dx dx to dx dy to dy dx. All right, so we're trying to paint this upwards. And you do see that we need two integrals for this, right? Because if I make it bigger, this is a shape, and when you try to go upwards, there's two different parts that's on the top, right? So if you're on this side, you start from here and you end there. If you're on this side, you start from here and you end there. So it requires two integrals. Got that? Is that good so far? All right. All right. And often when you solve these questions, it's good to know these coordinates. Now, these are easy. This is 4, 2. This is 4, 1. What's this?
1, 1.
It will be 1, 1. If you draw it carefully, it's just 1, 1. Or even if you didn't draw it carefully, you know that this point is on the graph x equal to y, right? It's a point on this line. And since you know that the y coordinate is 1, you know that the x coordinate should also be 1. And same deal here. What's this coordinate? 2, 2, because if the y coordinate is 2, and it's on this graph, y equals x, then it must be 2, 2. Okay. So that's going to help us to figure out the bounds easily. So let's first try to express this integral. If f x comma y, we're trying to do dy dx. Where do you begin? What is this equation? This one here, right? It's a horizontal line. Horizontal line have equations like y equal to value, right? And what is that value?
1.
Y equal to 1. So we know that y equal to 1 is where it begins. And then we have this one. What's that? In this picture, it's this one. What's the equation for this line? Y equal to x. So that's what you put here. And then what's your value of x? What's the minimum value of x in this domain? 1, right? The left end is 1. What's the maximum value of x in this domain?
2.
It reaches 2, right? And that's where you stop. So it's from 1 to 2. That's the first integral. Okay. Now let's try to fill out the second one. Now here it goes from this line to this line, and they're both horizontal lines. Therefore, the equations look like y equal to number and y equal to number. The bottom one is same as before. It's y equal to 1. What's the top one? What's the equation of the top? What's this equation? 2, because it passes through 2, so it must be y equals to 2. And then your x values go from where to where? 2 until? See, your x value starts from 2 and it ends at 4, right? So you know that you should write 2 and 4 there. Okay? And therefore, you can write it as dy dx, and you see that it requires you to write 2 integrals. Now, if you try really, really hard, then there is a way to represent this curve in a single equation using an absolute value. Let me try that. How does that work? X minus, you have this. Okay, so first I have this, and then if I have 1/2 x, and what do I need? If I plug in 2, that's plus 2. So if you have this function here, if you plug in 2, you get 2, right? If you plug in 4, 4 minus 2 is 2. Negative 1/2 times 2 is negative 1. And 4 divided by 2 is 2. No, it's off by. Should be good. Oh. Plug in 2. Why is it not giving me what I want? If I plug, sorry, it should be 1. If I plug in 2, you get 2. If I plug in 4, you check that this gives you 2, so it says it's a horizontal line. And if you plug in 1, you can check that it passes through this one too. And it has a, because it's this absolute value at x minus 2, there's a break, the line changes slope at 2. So this is a single equation that can represent the entire top. Okay. So if you really, really wanted to write the integral in a single integral, it will be from 1 through 1/2 x minus 1/2 x minus 2 plus 1 fx comma y dy dx, and your x values vary from 1 to 4. Okay, so this is same as that, but don't do that. It's just, I just was wondering what it should be, but it's not important. Okay. So just represent it as 2 integrals. That's much easier.